Okay, hello everybody. So today we're going to continue our discussion in Chapter 5, Section 4, and we're going to utilize all of the log properties that we have, or at least a lot of them, to begin solving logarithmic equations. So let's get started. The first equation you can see here just says solve the following, and we have e to the x plus 5 equals 60. Now, the first thing that you always want to do in the case of this, where you have an exponential, or an exponent, I should say, that has the variable in the exponent position, is to peel away everything else on the same side as the base and the power, except for the e to the x in this case. So we will subtract 5 from both sides, and we'll be left with e to the x equals 55. Now, the next step involves using some of our log properties to get the x down and out of the exponent position so we are able to solve for it. Now, there's a couple ways you could think about this or to do this. The first way that you could think about this is how to take something from exponential form and put it into logarithmic form, which is what we would do here to get the x by itself. The other way that you could think about this is that you could log both sides of this equation. So I'm going to show you both ways. It's completely up to you how you choose to do it. So if you look at this right here, we have an exponential equation. The very first rule that we talked about when we began these exponential rules is how to go from exponential form to logarithmic form. And if you recall, we keep the base of the power, which is e, and that becomes the base of the log. Now remember, when you have log base e, that is natural log. So what will happen is this becomes natural log, and then it's 55 equals x. And there you go. It's solved for x. The last thing that you would then do would be to take and type natural log of 55 into your calculator. And when you do that, as soon as my calculator boots up, there it is. Once you do that, you can hit natural log of 55 and you get 4.007. Now, the other way that you could do this, if you maybe are rusty on going from exponential to logarithmic form, would be to log both sides of the equation. And you'll see me do this pretty often too. And that's something else that you're allowed to do. It's an equation, and that equation, e to the x equals 55, is balanced. And so if you do one thing to one side, as long as you do it to the other side, that equation will still remain balanced. And since this is the base of the exponent is e, we are going to use log base e. Remember, log base e is actually natural log. So I will write in natural log on this side and then natural log on this side. Now, what you will see on the left-hand side now is that we end up with natural log of e. So we will utilize the power property to bring this x down, and we'll be left with natural log of e equals natural log of 55. Now, hopefully you recognize that this log, or natural log of e, is a log base e of e. And when that happens, it cancels, it turns into 1, and we're left with x equals natural log of 55. So either way you choose to do it is perfectly fine. We use two different log rules. In getting started on this, we actually ended up using about 3 on the right-hand side instead of just 1 on the left, but they both gave us the same answer. Now here's another equation, and this one will be solved in the same way. And again, you can either utilize the power property, or you can utilize how we go from logarithmic form to exponential form, or you can log both sides. Either way is perfectly fine. But as I said in the last problem, you need to isolate the base and its power. There can't be anything else with it before you can use any of those log properties. So the first thing I will do is add 4 to both sides, and you'll end up with 2, and then parentheses 2t minus 5 equals 15. Then you will divide both sides by 2, And so now we have 3 to the 2t minus 5 is equal to 15 over 2. And now this is there's a couple ways to do this. I'm actually going to use the second way that I showed you in the last problem. I'm going to log both sides. And when you log both sides, you always want the base of the log to match the base of the exponent. So in this case, the base of the exponent is 3. So I am going to take log base 3 of that side, and I'm going to take log base 3 of that side as well. Now, as you probably can see now, because we have log base 3 of 3, that will end up canceling. Before we cancel it, though, we need to bring this down in front using the power property. So we have 2t minus 5 times log base 3 of 3 equals log base 3 of 15 over 2. Now you can see the log base 3 of 3, this cancels, and we're left with 2t minus 5 equals log base 3 of 15 over 2. Now there's two more steps to do, and they're pretty easy. Now we need to isolate this variable t right here. And in order to isolate that variable, the first thing we'll do is add 5 to both sides. Now, on the right-hand side, there's no like terms to add that 5 to, so it will just be tacked on to the end of the equation. So we're left with 2t equals log base 3 of 15 over 2 plus 5. And lastly, we'll divide this by 2 and then divide this entire expression by 2. And we will be left with t equals log base 3 of 15 over 2 plus 5, all divided by 2. Now, in order to type this into your calculator, we definitely would have an easier time with the TI-84 than we would with the TI-83, because the TI-84 allows us to type this log base 3 of 15 halves in. If you don't have a TI-84, you only have a TI-83, you will have to utilize the change of base formula where you will type this in. And I'll write that out for a second, but let me show you on the TI-84 first. So on the TI-84, the expression that we had was log base 3 of 15 over 2 plus 5. Now, all of this is going to need to be put in a set of parentheses before we divide it by 2. So I'm going to go ahead and type that in the way you see it. We'll put a parentheses, then we will click Math and scroll all the way down to the bottom where you see this log base command. And when you can see, that gives us the ability to change the base to base 3. Then inside these parentheses, we will make it 15 divided by 2. And then outside of that parentheses, I'll put my plus 5. Now I'm closing the parentheses because I've completed typing in the numerator. And now we'll hit divided by 2. And we will get our answer, which in this case, t is 3.417. 3.417. Now, if you don't have a TI-84 and you're not able to type in this log base 3 of 15 over 2 with what I showed you on the 84s, you can use the change of base. Now remember, if I wanted to type log base 3 of 15 halves in, I would need to type log of 15 over 2 divided by log of 3. That's the change of base formula. And then from there, you would type in plus 5, and then you would divide that entire thing by 2. And that would give us the same exact answer. And just to show you how that would work, if I did put a parentheses and then I did log of 15 divided by 2, and then that entire log is divided by log of 3. Now I'm going to close out that parentheses and add plus 5. And then lastly, I will put divided by 2. Now I did need to have a second parenthesis at the beginning, which I need to go back and insert in there. Once I do that, second, inserts, put in my second parenthesis. So you need to use parentheses a little bit more because you need to force the calculator to do all of this stuff that you see typed first, and then add 5 to it, and then divide the entire expression by 2. And when I do that, you can see I get 3.417, which is exactly what we got when I used the other command. Now, here are some more logarithmic equations. This procedure that I'm going to show you is a little bit different than the last ones because, or how to solve these, I should say, is a little bit different because these ones already have the log in the equation. If you looked in the last couple of ones that we solved, there was no log in those. They were simply exponential equations that we had to use a log to solve for the variable that was up in the exponent position. Well, we can also have logarithmic equations that already have the log in them and that actually need to be converted from logarithmic form into exponential form so we can solve it. So as an example here, you can see we are natural logging x, and we're saying that equals 2, and we need to solve for x. Well, since we already have a natural log of a variable, we need to remove that natural log. The way we remove the natural log is by taking it from logarithmic form and putting it into exponential form. Again, that's the very first rule that we studied whenever we began talking about logarithms. So remember, the base of the log becomes the base of the exponent, and then the x and the 2 switch places. So this is natural log, so that means the base is e. So to convert this into exponential form, we would get e to the second power equals x. And you can see as soon as you convert it from its logarithmic form to its exponential form, you're done. You have solved the equation. X is e to the second power. Now, in order to evaluate that, you can simply hit the second followed by the natural log key, and it will give you e to the x. In this case, we want it to be to the second power. And when I hit enter, I get x equals 7.389. And there is my final answer. Now, the next one is done a little bit differently. This one is going to utilize the one-to-one property. And here's what the one-to-one property says. If we have log base 3 and then of something, and that is equal to log base 3 of something else, what we know is that these two things must be equal to each other. So this becomes a pretty simple problem. As long as the logs are the same and the bases of the logs are the same, then we simply just set 5x minus 1 equal to x plus 7. And we solve it by subtracting x from both sides, adding 1 to both sides, and then dividing by 4. And we get x equals 2. So that was a pretty easy one. The one-to-one property, when things are set up already for you, tends to be pretty simple, that you just set the things that are being logged equal to each other and solve. Okay, so here's another example of a log equation. This one's slightly different though, and so you'll see what we have to do before we can utilize in this case, we will use the one-to-one property. But what we have to do is we need to rewrite these so they are only have one log on each side of the equation. The one-to-one property only works if we have log of something equals log of something. If we have this extra log in here, we can't utilize the one-to-one property yet. Now, what I want you to see is that this is a log of something minus a log of another thing. And since those two logs are subtracting, we can actually utilize the quotient property to combine this log and this log into one log. Now, you always want to double check that the logs that you're combining and or using the one-to-one property all have the same base. In this case, there's a 6 there, there's a 6 there, and there's a 6 there. So they are all the same base. The next thing we will do is we will combine this. So we'll have log base 6 of 3x plus 14 divided by 5. Now on the right-hand side, we will not change anything. Now, once we've combined those two logs together, we will now be able to use the one-to-one property. You can see that this is log base 6 here, and this is log base 6 here. We do know that these two expressions are equal to each other, which means then that this has to equal this. So we will set 3x plus 14 over 5 equal to 2x. Now we need to solve for x. In order to solve for x, we need to combine our x's. So we need to get rid of this 5 first. So we will multiply this side by 5 and multiply this side by 5, which will give us 3x plus 14 equals 10x. Once we do that, we can subtract 3x from both sides. And then divide by 7. X equals 2. And there's our final answer for that one. Okay, thanks for listening. As always, if you have any questions, feel free to email me. Have a great day.